So yeah, okay, perfect. Complementing a little bit, so my background, of course, is computer science, and I just finished my PhD degree, which is about AI and data science education. And my focus, as Molly said, is especially non-STEM, and STEM means statistical, technical, mathematical, engineering, right? So I focus my technology and data science teaching to this audience, in particular to humanities, and even within humanities, probably business-related course. So I'm also a professor in a university called IBMEC in Brazil, with courses especially related to business administration and economics. I guess some of you folks here are from this background. And here at FIU, I'm also validating my work. We're gonna use the tool that I'm gonna show here as part of the PhD. And here at the FIU, I'm work under Professor Geary group, which is BioOrg. It's informatics applied to biology or biosciences. So I'm validating part of my work with life science and biologicals majors. So it has been quite good results so far. All right, so I'm a little bit about a word of time. We have somehow a lot of ground to cover. I wanted to get started as soon as possible. So folks, it's very practical. Feel free to follow along as I present. If you wanna lay back and try to reproduce and do some of these afterwards with the recording and so on, it's also feasible. If you're interested, have this material available here. Molly send it on the link also. Can reproduce afterwards. But if you want to follow along, feel free. And if you want to interrupt them along the way, feel free to either through the microphone or to chat. Don't worry about it. Feel free to interrupt it anytime, right? So we're going to have 2 days, right? To have today and Thursday. Today, going to focus on descriptive analysis. So we're going to look to past data and try to summarize these data, try to use some very simple graphs like bar charts, pie charts, line plots, and so on. And we're going to start using a block-based tool, which is very visual and very intuitive in order to introducing data analysis and also coding. So the idea is as soon as possible, you can leverage coding to do data analysis. And if you are worried or nervous about coding, I can guarantee you that it's going to be quite simple. So currently, that's the right time for non-technical people to start using coding, and coding mainly as a data analysis tool. Of course, you can use coding to automate many different tasks, to create application, create websites, create games, automate, I don't know, day-to-day tasks. It's totally possible. But for non-STEMs, usually I say that coding and programming, it's a very flexible tool to do data analysis, right? And why is the right moment? Because right now we have quite simple languages. So the way that you write code is quite simple. For reference here, I'm going to use Python. Molly and Digital Library Group had a couple sessions, quite longer session a couple months ago on Python. For the ones have some familiarity on Python, it's going to be very straightforward probably. For the ones here that have no prior contact to coding or Python, don't worry at all. It's going to be a very gentle introduction. You'll be able to see that it's not as hard as it's look or as it sounds. And secondly, we have now within the computer science world, cloud computing, right? So cloud computing, and using a fancy word, it's making computing resource almost ubiquitous, right? So it's probably soon enough, computing resource is going to be as simple as using, I don't know, electricity, water, heating, and so on. We just hit a button and don't worry about the details, how to install, how to configure, anything like that. So we are more or less at this point. So we're going to set up a very simple Python environment without installing or configuring anything in your machine. You're going to run everything on cloud, and in a very familiar environment. We're going to create that within a Gmail, Google account, right? Probably every one of you have a Google account, like a Gmail. Actually, within Google Drive, we're going to use a free Python cloud environment. We're going to see that in a second, right? So, all right, just get started and have the deck here as a guiding. But actually, as I said, most of the material in the presentation is very practical. So we are going to use this block-based tool. It's called Blockly. That's this guy here, the link that I just sent you. So Blockly, or actually Blockly DS, Blockly is a tool created by Google in order to introduce coding for either STEM or non-STEM. So we have like simple blocks here related to classical programming elements like if, loops, list, mathematical functions, and so on, variables and functions also. And then I extended it with some other features, some related to classical AI analysis. Again, seems also very complex or sophisticated, but it's from the end user perspective, it could be as simple as a black box that you do numbers and forecast of values and categories. We can definitely have in the near future a similar session like this, focus on those. For now, we're going to focus mainly on not predictive, but descriptive analysis, right? We're going to analyze past data and try to drive insights from those data using some techniques and graphs, right? So we're going to use quite a lot data visualization and data analytics, right? So starting with a data set. So here I have these data sets. And the data set is a simple spreadsheet, or actually a CSV file. Let me show the link that I just pasted on the chat. It's a regular CSV file published on the web. What's CSV? CSV is very similar to a spreadsheet. It's several lines. Each line, it's a record. The first line are the headers, and each cell or each value is separated by a comma. That's why it's called CSV. It's comma separated values. If I download it here, within my computer, if I click twice, it should be able to open within Excel or whatever spreadsheet tool you have. So it's as I said, it's a simple spreadsheet in its mostly simple and raw format, right? I could have it here locally, but as I have it published on the web, it makes easier for us to share and to start our analysis, right? And the data set that I have here, it's also very simple, like a dozen rows, dozen records related to different students and their grades. So from different courses like business administration, law, economics, they have like 3 different midterms or different exams, and a final grade, which is a numerical value, and associated with this numerical grade, we have a score, which is very similar to US-based grading and scoring, right? So yeah, I have this URL here, and then I can use my data analytics menu, and I have a couple of blocks related to loading data, especially CSV. I have this read data frame. I have the dictionary, which I created manually, my data. And then if I have a local file, I have this open file one. So let's use this read data frame. And what's a data frame? Data frame is the representation of a tabular data, as we have on the CSV, in a programming language memory, right? So is a very usual term for the ones that are familiar with either Python, R. Data frame, it's a very usual term. You can think as data frame as a table, right? Or as a spreadsheet. So I can connect this read data frame component within text menu here. I have these codes. So this codes I'm gonna use it to connect it here. And then I can paste the path to the data set. And then the output of this read, I can put it in a graph visualization. So within data visualization, Yes, it's try to zoom in. I hope it's good, the visualization for you guys. So within data visualization, almost at the bottom, we have table view. Table view. I can connect table view here and hit play. So once I hit play, I'm executing that logic. So the idea of the blocks is to create a logic of programming, and programming it's something simple enough as a cooking recipe. You have a sequence of steps that the machine has to execute and produce the result that you expect, right? The challenging part is for you to detailing the set of instruction in order to the machine to execute as you expect. But our first command here was simple enough, right? We had a block for reading a data frame, and then this data frame that's the table in memory, we're putting it into a table visualization, so it shows the results. A lot of times it may be useful to use variables. So variables, again, it may be like a fancy word or something like that, but you can think as a variable as like moving boxes. It's only a box in which you put information. It's very important that you label it correctly, so you make sure that you understand what's in that box once you want to use it. And then as soon as you want to reuse it, the information that's saved on that box, on that variable, you can refer to the label that you have on the box, right? So we could do something like within the variable menu, I could create a variable, and let's call a variable. It's ideally should be a very suggestive name, but let's create something as simple as df, for short for data frame, right? And then now I have the setdf, which is in order to save information in that box, and then this df block here, that's in order to read information from the box. So I'm going to use both of them. So setdf, I'm setting the read, this data frame that's in memory, saving that box. And as soon as I want to read information from that box, I can use the other block, this one, the reading df. And then I connect through the table view. It's going to be very same results. I only organize a little bit better, separating and having this variable, this box, so I can reuse in other points of my code, right? And again, code, as I said, it's something as simple as cooking recipe, right? You have to define a set of instructions in order to the machine to execute. So normally we connect these blocks, and if you're doing on the fly with me, you're gonna hear a very smoothing sound that something is connecting. It's very interesting. But yeah, you have the sense now that the machine is gonna execute these two rows in a sequential manner, right? First, read the data, put in the F, and then whatever is in the F gonna show us a tabular data. Again, if I hit play, I'm gonna have the exactly same results. And then my point with the blocks is, again, it's very useful for us to structure a rationale and a construct, but probably soon enough, you're gonna be more productive in terms of using coding as data analysis tools. Again, data analysis tools as programming languages are very flexible and very powerful in order to do whatever analysis you want to do, and also being able to process as much that data as you want to, right? Especially leverage cloud computing environments, right? And then it's this conversion from programming logic into actual code. It's something as simple as doing this translation that even machines can do, right? Even within here, I have these tabs that do this translation. So if you want this code in JavaScript, it's available here. If you want to do it in Python, it's here. In R, it's here, and so on, right? Let's try Python. I'm going to copy the Python code here, and then I can transition to a Python environment. And as I said, we don't have to install anything or configure anything. You simply go to a Google Drive account. If you're in your Gmail account, regular Gmail, and you go to here, Google Drive. Let me select a good folder to everything to be organized. We can create, as you create a new document or a new Google Sheets or slides, you can create, there is a more button here. We have something called Google Collaboratory. for the ones that heard about it, that is Jupyter Notebook. So Google Colaboratory, it's the equivalent for Jupyter Notebooks. The difference, Jupyter Notebooks, usually you have to install on your machine and do the configuration. Colab, it's totally available on the cloud and free of charge up to certain machine computing power, right? So in case you don't have that option, it's very easy. You just click Connect More Apps here, look up for Colab or Colaboratory, and then you click on this, and you should have an install button here. Right now, mine has uninstall as it have installed already. Right? Once that you have installed, again, it's quite simple. You go here on the top left corner, new, more, Google Colaboratory. And it's also very interesting. The name suggests collaboration, right? It's interesting that in the cloud, you can even share with other colleagues, and you have all your codes, all your notes, all your results from data analysis within a single environment that can be adjusted, updated, and reviewed by as many people as you wish, right? You can have a good name here. Let me put Python. I could have a better name. I'm terrible of naming things. But anyhow, I'm going to paste the code here. And I'm going to hit play. The first time that I hit play, here it says allocating, initializing, connecting. It takes a little while, a couple of seconds to spin up a machine. So Google is providing us for free somehow quite okay machine. It's better than my Mac laptop that I have here. So it's 100 gigabytes of hard disk plus 12 gigabytes of RAM. So it's good enough, right? And you have exactly the same results as you had on Blockly. You have now here encoding. And what's the point again? Soon enough, probably for you, going to be faster, more productive to adjust coding directly rather than drag and drop blocks. So Blockly is more a leveraging tool in order to transition from general logic of data analysis into proper coding. And again, even if you have never seen any coding or never seen Python, it's simple enough. What kind of things we're doing here? We're importing here a library called Pandas, or for short PD, and this library has a bunch of built-in functions. One of the functions that's available on Pandas or PD, it reads CSV, which is reading a data file that's published on the web, as parameter, which is within the parentheses here. I'm forming the path for the CSV that I mentioned. And the second row, the second command as we had on the block, we are printing, we're showing on the screen whatever is in the F, which is the tabular data as we saw, right? I guess it's simple enough, right? So far, so good. Any questions and points? Feel free to interrupt me, send me chat. In case I'm going too fast or too slow, please let me know so I can adjust. Simple tasks. I can, within the whole data frame, if I want to analyze a single column, if I want to select that column, there is a block related to select. Let's go back to block. If I want to not show all columns that I have here, if I want to show only the student name, we have a column called student. So let's throw the block of selection. Select here and select. It asks me of the data frame, df, and the field name or the field's name. Within that gear here, I can add extra fields if I want to. So if I want to, for instance, the name of the student, I got the quote again, right? To inform the name of the field, the name of the student. And let me say if I want the score, which the letter grade for them. And then we have it. So within the whole data frame, I selected a couple of columns, which is student and grade, right? And again, if you want to keep switch back and forth between blocks and code, it's totally a very good idea. That probably is the very easy way to start getting familiar with coding, but very similar here. I can copy the code here, or even only this part, because the import part, I did it once. I don't have to redo it again. Like this only last couple of line codes will be enough, or actually the last line of code would be enough because the first one exactly the same, right? So here I'm The only thing that I'm doing is within the F, I'm selecting a couple columns. So the syntax on Python is to use those brackets in order to select columns, right? So we, let's say, focus on a specific column or a specific pair of columns, but if you want to focus on a specific set of rows, if you want to filter rows, there are also a command for it, that is a block for it also. So if instead of focus on columns, if I want to focus on rows, if I want to filter rows within data analytics, we have here the filter block. Again, I can connect it here, connect the data frame, and put my criteria or my criterias here. So let's say if I want only the student with the grade greater than, we have equals, different, greater than, equal. Let's use that one. Students, let's say the passing grade is 7. So I want only the approved students. So within the similar to text that I have the quote, if I want to use a numerical number, I'm going to go to math, get this number here, 1, 2, 3, and the number, I don't want a 1, 2, 3 or 123. I want the number 7, right? And then I can filter out only the students with grades above 7. Those are the students with grades above 7, right? So we have all the students here that pass the class, right? And again, you can keep switching between blocks and codes, right? So if you want to have an idea how do you filter rows on Python, would be something like this. It's again the F, these brackets, and within the brackets we put the criteria. The criteria here is the F column grade being greater equals than 7, right? So that's the way to filter rows. And again, don't get afraid or don't get scared about Python code in particular. It gets used as much as you use it. For now, I guess it's more important to focus on, again, the programming logics using blocks, right? So what else? Filter rows. Something very usual would be to do data consolidation, right? Here we have a very short data set, only like a dozen rows, but could be 1,200, could be 12,000, could be 12 millions, whatever number. So could be all the students at FIU could have, I don't know, 6,000 students with all these grades. If I'm the dean or a course dean, I don't want to look throughout over 1,000 rows for each single individual student. I probably gonna want to do analysis overall grades or average throughout different courses, for instance. That's a very usual operation to do data consolidation, summarization. So we start with a large set of records, and if you want to reduce that for a much shorter number, you can do those kind of consolidation. If you somehow are familiar with Excel or the spreadsheets, it's something equivalent to a pivot table, right? I'm not familiar with pivot table, but I can show it here the idea. So within Excel, let's say that I want to calculate the average grade by course. I can, within Excel, for instance, insert a pivot table. And then normally I would aggregate by a categorical column, which is the course here for us. So on pivot table here, I can drag course to rows. And then I want to do a mathematical calculation on top of a numerical value, right? For us here would be the grade, right? So I'm going to drag grade here to values. And Excel try to predict whatever mathematical function I want to throw. So he used the sum function. It's not sum that I want to use on this case. I'm going to go here on field settings and change it instead of sum. I wanna see average. So I have the average for each course. So business administration have a little shorter grade, a little below the passing grade of 7. So they have 6.6. Economics a very good grade, almost or close to 8. And law in between those with the average grade of 7.2, right? And you have that. Instead of, again, looking for each student row by row, I have a general overview how my on average, my courses are going, right? And if I want to compare that information, I probably it would be very useful to throw a bar chart, right? I can select this information here, and in Excel, I could go here and throw a bar chart, right? So it's very similar operation that just did in Excel for a very simple spreadsheet, we could do using coding and have the ability to process not like a dozen rows, but probably like 12 million rows, which would be very hard to do, or to be very hard to process 12 million rows in Excel, right? So back to blocks, let's try to do this very similar operation. Let me throw the filter away. And within data analytics, we're going to use two blocks, one for grouping purpose and the other one to do the aggregation function. So we're going to first group by. So let's connect the data frame here. And we want to group by a categorical column. The categorical column that interests us here, it's the course, right? So I'm going to group by course. And then once it's aggregated, let's apply the mathematical calculation on the numerical column. So I wanna throw this aggregation function here. I have different aggregation functions, sum, count, max. It selected the one that I want to use. I want to calculate the mean on top of the column grade, right? Yeah, that's pretty much it. I can hit play, and I have exactly the same results that I had on Excel. A business administration, 6.6, law 7.2, and economics almost a grade of 8, right? I can even organize this information, again, using variables, right? I can have a variable for this aggregated value. Again, I should have a better name, but let's call it AGG. And I can do like set AGG to this calculation and do the table view for the variable AGG. Same results, only organize a little bit better my code, right? And if I want to keep switch to Python, I can definitely keep doing that. So again, as you want to get a little bit more familiar with Python, the operation was quite simple, right? With a single, very simple line of code, you can do this whole aggregation, this whole pivot table feature, right? Within my data frame, I use the group by function, aggregated by course, the categorical value, and then apply the mean mathematical function on top of the numerical column grade. And then I saved this result in a variable called AGG and said to Python to print this result, right? So I printed this result as you have it here. It's as simple as that. And as I said, you probably will be able to progress again very quickly. I'm going to do the opposite now, but of course I'm going to go back to block. But from here, for instance, if you want to show the bar chart, it's something like within AGG, the aggregated table, I can simply say or use the function plot, which is to plot a graph. And within the parentheses, as a parameter of this function, I can say what type of, or actually what kind of graph I want to use. The kind of graph that I want to use, it's bar chart. That's simple, right? From previous or for more legacy program language like C, Java, Pascal, assembly, and so on, if you show to like an old-timer programmer that is that simple to create a bar chart on a program language as Python, they're gonna be probably impressed. And I don't know if you had this prior experience in doing in other language, but in a very short command, you have a quite powerful functionality that generate graphs and focus again. You probably, if you are non-STEM, you are not really caring about coding. You are not really caring about even the beauty of the graph. You are more caring about the insights that you drive from your results, right? So if I'm like the dean of these 3 courses here, I probably had to do some action items here. Like if I can even use Colab to do so. Not only code, I can add text. So within text, we should have I don't know, game plan for business administration and make sure that they get in the same pace of economics and so on. But again, you probably wouldn't care that much for the code itself, but you probably would care quite a lot about what insights could drive from raw data. And again, programming could be a very powerful tool to do so, right? I do the opposite, right? I start for coding, but let's go back to our blocks. The blocks would be pretty much the same. I only would have to change the table view graph to a data visualization chart, and I'm gonna throw the bar chart. And again, bar chart, it's a very, very useful chart to do this comparison, right? If you compare values, so I'm gonna compare the average between business administration, economics, and law, bar chart, it's probably the perfect example to do so. So I can simply connect the aggregated result here, hit play, and I have exactly the same result, but running here on blocks. And again, I can keep switching between Python and blocks to do this translation. The Python translation actually is going to be a little different than I show, because here on blocks, it uses a different library from Python. It's very usual to do the same thing in several different ways. There are libraries, which is it's a package of different pre-built functions developed by many different people. So there are definitely libraries and functions that do the exactly same function in different ways. You can pick and choose whatever you wanna. So let me try this way. It's another way to create bar charts using this other library called Seaborn, and Seaborn is too long for coders to keep retyping, so shorten it as SNS. And it's again quite simple. It's SNS. We use the bar plot function, and you say on the x-axis, I wanna have the name of the courses, which are the index for our table. It's this is the index. ADM, economics and law, the index, and the values are this average here. So the x-axis would have the courses, and the y-axis would have the average, right? Would have the average. So Seaborn had exactly the same result, a little different on the presentation, the aesthetics, a little bit of color, different fonts, but again, the same results. Oh, and this last part that I have here, it's if you want to throw additional information like title or caption for the axis, it's possible to do using this set function. If I'm not using it, I can simply remove it. I have these very same results. So what I want to show you guys is this, as even different ways of doing the same thing, both for all versions. It's quite simple enough, right? The other one, I had the data frame, use the plot function and say that I want to plot a bar chart. And this one, I used a bar plot function from another library called Seaborn, and I simply formatted whatever information I want to throw at the x-axis and whatever information I want to throw on the y-axis. It's as simple as that, right? So again, bar chart is a very useful graph for comparing data. But if you want to, for instance, analyze proportion, if you have the idea of the whole of 100%, and I want to see like percentage of those proportion, probably a little bit controversial graph, it's the bar chart. It's controversial because if you use it without like percentage, it's quite hard for a human eye to perceive differences here. But anyhow, it's still a good graph once you want to analyze those proportions, right? So let's do something similar to what I did, but a little different. So again, I want to do aggregation. I want to still aggregate by course, but instead of calculate average on grades, let me simply count as many students as I have by course, right? So let's count the student name. So the column will want to be student, the student name, right? And instead of a mean, I want to count, right? I want to count. And now instead of a bar chart, I want to throw pie chart, right? here we have it. So we have the captions. The blue is business administration. So business administration and law, they have the same number of students, 41%, which is 5 each for the total, for the 100% of the 12 students that you have, and only 2 of economics of 12, which represent 16%, almost 17%, right? And again, I can keep switching between blocks and coding, right? On coding, I can grab some lines. For pie chart, we are using another yet library because Seaborn, funny enough, Seaborn has hundreds of different graphs, but it doesn't have or doesn't support pie charts. So you're going to use a library called Matplotlib, and it's a little bit longer the name, but anyhow we're shortening it to PLT. And then if you're again getting step by step a little bit familiar with Python, so we are importing PLT, we're doing the aggregation again. So the aggregation is a group by course, and then applying the count function over the student name, right? And then using the PLT, within the PLT library, you use the pie function, and for the X values, let me do it in 2 steps, right? So on the X axis, I'm using the aggregated values, which are those numbers, and the labels of each slice of the pie are the index, right? The name of the course, administration, law, and so on, right? And you have a very similar graph as you just had on blocks, right? So far, so good. Again, guys, feel free to interrupt me either over the phone, over the mic, or on chat. Again, I hope I'm not going too fast. The last type of graph that I want to show you guys today is the line chart. Line chart is very useful to analyzing trend. So bar charts very used to comparing values. Pie charts very useful to analyzing proportion. But if you analyze trend, probably the line chart is the most useful one. On that case, we should have on the x-axis a time series value column, either if it's year, day of the week, hour, seconds, whatever time scale you have, that should be within our x-axis, right? And on your y-axis should be a numerical value that varies alongside that time series, right? So I have a different data set here of COVID cases. Let me throw it here on the chat. Let me show it a little bit. Again, it's a CSV file, a little longer file with, I don't know, 500 rows or something like that. That starts at early COVID days, so start at January 23rd of 2020, and it have the new COVID cases for Brazil, India, and the US. So of course, Brazil, US have very little at the beginning, and then starting ramp up at different times, and it goes until not the end of COVID, it go until mid 2021. Yeah, it go until the end of August 2021, right? But so let's work with this guy then. Going back to blocks, let me throw away most of the stuff that I'm doing here. To throw away, I guess you realize that, right? I'm drag and drop this stuff to this trash bin here. Let me throw away this. And to the F, I'm going to inform a different file. I can visualize that as a tabular data. Very same idea. Tabular data, again, repeating what I did recently within data visualization, table view. And for table view, I'm going to connect with the variable df, right? This reading block here, and connect these two instructions in a sequential manner in order to the machine to know the sequence to process. Let me hit play, and I have exactly the same results on a more organized view, right? I have each date, again, starting back at January 2020 up to August 21st. and different columns for Brazil, new COVID cases, India, and then US, and again, it goes until August 2021. All right, so I wanna show the trend, right? I wanna use a line chart. So let's go to data visualization, line block here. And as I said, on the x-axis, I should have a time series. So within my data set, I should use the column date, as you have it here, right? Column date. So if you remember, we have a block to select specific columns, right? Within data analytics, we have the block here to select the different columns. So I'm gonna inform data frame DF, and the x-axis, I wanna the column date, right? Quite similar, and I can use a nice feature here. I can right-click the block and ask to duplicate it. And the y-axis, let's say if I want to analyze US cases. So the column that I want to select for the y-axis, it's the US column, not data, not something else. So yeah, that's pretty much it. We are good to go. And here we have it, the curve, and you guys probably had that memory how COVID hit hard by the end of 2020, and then a second wave or a large second wave, have like 4 different waves, right? Around April 2020, and then by summer 2020, over the winter of between 2020 and 21st, and by summer 21st, you guys probably remember those wave of COVIDs. We're going to compare that, for instance, with Brazil. It was more or less the same, a little delayed in comparison to US, but more or less the same behavior. But anyhow, keep switching between code and blocks. Again, I can go to the Python tab, copy this block, throw at Colab. Right, so I'm same operation from Pandas library PD. I'm reading a new CSV, which is this path here for COVID cases. I'm printing this table. I could even throw that away if I wanted to. Yeah, probably makes sense. Yeah, I could, for instance, yeah, I had that print because I had this table view. I could drop this table view altogether if I wanted to. Yeah. Probably make more sense. But anyhow, I threw away the print, the table view, and then here, very similar to had like from Seaborn, the bar plot in which we form the x-axis and the y-axis. Seaborn also has a line plot, and then we form on the x-axis the column date, and the y-axis the column US. That's it. That's as simple as that. Here it is. And you have this very same results now in Python using Seaborn library. And again, the set part here, it's about setting titles and so on. If I'm not using, I can drop if I wanna. I have the same results, right? Back to blocks. We don't have to limit yourself to a single column. I can add additional columns here. So on this gear here, I can drag from left to right other items. So I'm gonna open other slots here on my block. And then on these slots, I can form different columns, right? I could form not only US, but I could throw Brazil, I could throw India, and I can compare those trends along time. Here it is. So as I was mentioning, Brazil, let's put India on the side for a minute. Then I can show India back. So Brazil, it's quite similar to US. It was only phased. So our first wave, it was like few weeks after you guys, and then over the end of 2020, more or less the same. I'll have our peak a little phased from you guys, and then by 2021, more or less the same. And the scale was a little bit different. I guess here was even as proportion to the population, probably more or less the same. US, it's a little bit over 50% more larger in population in comparison to Brazil. And India, if you throw India now, India was a little different. India took longer to start in at least formal reports of COVID. But once they had, so they have quite a large wave by the fall of 2020. And then by 2021, they had a quite large peak with days with over 400,000 new COVID cases by day. So it's definitely an impressive number. All right, guys, make sense. So in short, we saw quite simple operation of summarizing data, something if you are familiar with Excel, like pivot table. We start with numbers, various rows, and if we have to shorten that for a subset or for compilation of those, the summarization, consolidation operation, it's very useful. And then we use 3 classical graphs. If you want to compare, use the bar chart. If you want to analyze proportion, use the pie chart. If you want to analyze trend, we can use line chart. And we are all the time using this block to create this rationale, so you get familiar what kind of analysis or some of the techniques of data analysis. Again, for now, we're talking about descriptive data analysis. We're looking to past data and try to draw insights from that past data using consolidation graphs. But also we could use those in the near future to do prediction using, let's call it sophisticated algorithms. But again, from the end user perspective, they are quite simple, right? And again, the blocks, it's a transition tool that you may want to soon enough move to coding. And again, you don't have to be scared about coding. Using language like Python or R within a cloud environment like Google Colab, it's simple enough. You can simply probably don't care that much about coding and leverage coding again to analyze the data and draw your insight, draw your action items. That's important for your day-to-day, much more important than the code itself. That's a very good tool to leverage that as you keep switching from one to another, and probably soon enough, you're going to feel much more productive adjusting code directly rather than drag and drop blocks. So blocks, it's a transition tool. I had a proposal. We have like less than 10 minutes. I have 2 exercises here we can do now, or if you want to do on your own, it's fine. We have a quite simple exercise with a simple data set. We can try it now if you want. I can give like 5 minutes or so for you to try, and then I can solve it. And then I have a more challenging activity. You could grab your own data set from this famous website called Kaggle. I don't know if you've heard about it, but it has data set for many different topics. So like for movies, Fortune 500 companies, YouTube, stock codes, animals. That is US Census data, for instance. We have probably data about most of the subjects in the words. It's not most of them are like well-organized data. It's quite easy to use it directly. So I put it as a challenge. If you want to try with your own data, feel free to use either from Kaggle or for other data set that you have. We can review some of it on Thursday. And for now, if you want to wrap up and close with this more simple exercise, I have this other data set here. It's a data set of a company with few orders. So we had the type of the product. So the company, a particular department, the administrative department ordered 3 reams of A4 paper. Sales department ordered 3 boxes of pencils. HR ordered 10 boxes of blue pen. So that's, again, it's a quite simple data set. And I want you guys should try to do, and I can throw like a 5 minutes or so. I wanted to present a bar chart aggregating the total volume of purchase per product, and another graph, the total purchase per department. So let me throw 5 minutes, or if you guys want to try it, then you can solve it together. And just make sure, if you have no idea where to start, let me give you a hint. You can again read a data frame with this new path. It's normally quite useful or useful to use variables. I can visualize the data using data visualization menu, table view, and I can throw the variable here, right? And I can see the purchase that I mentioned. The administrative department bought 3 boxes of A4 paper, sales brought 3 boxes of pen, and so on. And then the question was, how do I aggregate it per product, right? Totalizing, doing a sum of purchase per product, and then per or by department, and show that in a bar chart, right? So we have a very good tip here where when I go, we want to then aggregate, right? We're going to group by, the data frame is df, and I'm going to group by initially by product, right? My product. And then I want to calculate a mathematical function over a numerical value, right? So I'm going to use the aggregation function. We use the mean, we use the count. At this time, we want to use a sum, right? You want to add up all these purchase. And the purchase are on the quantity column, right? So I want to apply the sum function over on the quantity column. So if I connect it for a table view, I would have the pivot table, quote unquote, right? I would have the product. Oh, and sorry on my end, I guess I have an extra space here. So I have make sure I'm gonna adjust this data set. This extra space here gonna be a little annoying. So I have to have this extra space on the column name here. I have to do this correction. Yeah, so, but anyhow, once I throw that space, here we have it. The total ordering of A4 paper, there are 15 rims, 20 boxes of pencil, regardless of the department, right? 16 boxes of blue pens and so on. Again, regardless of the department. But I don't want to see that, or the question, I don't want to see that as a tabular information, a pivot table visualization. I want to see that as a bar chart. So instead of using a table view here, back of data visualization, let's throw a bar chart, right? And here we have it. So you can see the most ordered product is black pen, followed by pencil and blue pen, and a little bit of A4 paper. And again, if you want to keep switching between blocks and code, it's quite simple. Let me throw another variable here to organize it better. So let me have the aggregation within the AGG variable and bar chart for the aggregated data, right? Same results, but my code gonna be much easier to read. And here we have it, right? Same graph, in a different visualization. Of course, you can adjust a little bit the organization of this caption here, the titles. But anyhow, what I want to show you very quickly is this. I can even do it directly on code. As I said, coding probably going to be more productive soon enough rather than blogs. So the second question is, how do this totalization by department, not by product? So instead of product, I could have here the depth, the department. Oh, there is an extra space, my bad. I can group by department and do the sum over the quantity column, and again show the bar plot for the department and for those values on the y-axis. So here we have it without even going back to block. I did a simple change of the name of the column here, and now I have a completely different graph with a completely different analysis, right? I can see that HR is the department that orders more products for my company, followed by an administrative department, and then sales. Guys, I guess we are right at time. So I want to thank you again. I want to leave my contact information in case you want to, between today and Thursday, had any doubts, any problem, feel free to reach me. And again, if you want to reproduce this material throughout that period, feel free also to try to download the PDF, rewatch the record, and contact me. My pleasure. See you guys Thursday. And Molly, sorry, I guess I'm right at the time.
No worries. Yeah, no, this is great. Yeah, same time Thursday. I will send out a recording to everybody who registered in the meantime, in case you want to go over it again. But thank you so much, Louise. This is Blockly seems like a really useful tool for sure for folks who want to do Python, but maybe or R or anything like that. It's nice that you can interchange those different languages as well. Cool, thanks so much. And I hope to see you all again on Thursday.
See you guys. Bye-bye.
Bye.